Let's look at OpenStax University Physics, Chapter 16, Problem 48. Consider the wave function y of x and t is 3 centimeters sine 0.4 inverse meter x plus 2 inverse second t plus pi over 10. What are the period, wavelength, speed, and initial phase shift of the wave modeled by the wave function? All right, let's write down our knowns, and those are basically this long equation. So we have y of x and t is 3 centimeters sine 0.4 inverse meters x plus 2 inverse second t plus pi over 10. And then we're looking for the period, the wavelength, the speed, and the initial phase shift of the wave. So I have here a diagram. It's basically a sine wave. It's just a sine wave that starts at x equals 0, at time equals 0. It's a very generic sine wave. I don't know that this sine wave actually models this equation, but just for a reference, here is a sine wave. And then we know that the equation for a wave is given by amplitude sine omega t plus or minus kx. If we use the plus sign, that means that the wave is traveling in the negative x direction. If we use the minus sign, it means that the wave is traveling in the positive x direction. So in our problem, we have, first of all, we have omega t over here and kx over there. So these two are switched. So since the kx has a positive sign, it means that this wave is traveling in the negative x direction. So we can say that this is going in the negative x direction. Now we know that omega is 2 pi over period, and we know that k, the wave number, is 2 pi over wavelength. So if I'm going to do this. I'm going to write y of x comma t is equal to a sine, so that is kx plus omega t plus phi. So why do I have this phi here? What is this phi? We haven't seen it before. If I set x and t equal to 0, so I have the wave at x and t, then it looks like my wave still has an a sine phi. So the wave doesn't really start at 0, it starts somewhere else. So this axis wouldn't go through the equilibrium point of the wave, it would go through somewhere else. So we automatically see that this phi is pi over 10, so our axis should have been somewhere here. This should have been our x and t equals 0, and that would be the pi over 10 phase angle. So let's just write that down. So phi is pi over 10, and that is actually the last thing that the problem is asking us to find. Now, we need to find the period, so I'm going to set this equal to that and have omega, which is equal to 2 pi over period, is 2 inverse seconds. So that means that the period is going to be 2 pi over 2, or just pi, which is 3.14 seconds. Then I'm going to match up the k with that value there and say k is 2 pi over the wavelength and k is 0.4. So that means that the wavelength is 2 pi over 0.4, and that is 5 pi or 15.7 meters. And the speed of the wave is lambda times frequency, or lambda divided by period. So that is 5 pi divided by pi, and that is just 5 meters per second. So we have a wave traveling in the negative x direction with wavelength of 15.7 meters, a period of 3.14 seconds at the speed of 5 meters per second, and it starts with a phase shift of pi over 10. I guess I should box this one too. And here we have the answers to the problem.